curve, find a value given its z-score, and then find a value given a probability. Okay, first we're going to find a z-score given a probability. So we'll be given a probability or cumulative area under the curve, and then we got to transform that into a z-score. So step one, first you got to find the cumulative area to the left. Then you got to find that area in the standard normal table, or later with technology. And then line up the z-score associated with that area. And I'll give you an example here in a minute. Okay, use the standard normal table, finding z-scores. Find the z-score that corresponds to the cumulative area of 0.9382. So that's already the area to the left. So 0.9382. So we have to hunt around in this table until we find 0.9382. There it is, right here. So that z-score is going to be, so go over to your left, 1.5. and then up to 0.04, so 1.54. All right, make that a little thinner. There we go. Find the z-score that has 8.69% of the distribution's area to its right. So we need the cumulative area to the left, so we're going to have to first take that area to the right and subtract it from 1. It's going to be giving me 0.9131. So now I'm going to go to that table. Use a different color this time. Let's use green. 0.9131. There it is. So that belongs to a z-score of, there's my hundredths place, my ones and tenths place. So 1.36. Right. Now there's an easier way, because that's kind of awkward hunting around the table, and then if you're in between a couple values, you're going to have to find the average. So a little bit more efficient ways to use technology. So I'll be using the TI Nspire. Let me just go ahead and maximize this for you. So it's, all right. Okay, find the z-score that corresponds to a cumulative area of 0.7454, so that's our area to the left. So we've went from z-scores to probabilities. Now we're actually going backwards. We're going from probabilities / cumulative area back to z-scores. Before we use normal CDF, now we're going to do the reverse of that. So kind of think of that. So menu, probability, distributions. Now we're doing inverse normal. So our area, this area is always area to the left, is going to be 0.7454. We want a z-score, so we're going to leave our mean 0 and our standard deviation 1. So it's 0.6600, 0.6601. So when you use a calculator function on your calculator to get z-scores or probabilities, it's always good to write down the function, which is inverse normal, and label your inputs. So our area to the left is 0.7454. And because we're looking for a z-score, we need a mean of 0 and the standard deviation of 1. And we get a z equals 0.6601. Usually z-scores are rounded to the hundredths place, so let's do 0.66. Okay, find the z-score that has 32.75% of the distribution's area to its right. So again, we need, calculator also needs area to the left, so we're going to do 1 minus that first. It's going to give us an area to the left that's 0.6725. Now I'm ready for the calculator. So menu, probability, distributions, inverse normal, 0.6725, leave the mean 0 and 1, Z equals 0.45. All right. So now we're going to find z-scores given a percentile. So percentiles are also described as the percent of data below a certain value. So first we'll sketch and shade the percentile as a cumulative area to the left using the normal curve. We'll use the standard normal table, or I'm going to actually jump to using technology to find this area, and then, or to find that area associated with the z-score and identify the z-score that matches with that area. So find the z-score, and this is how they use notation for percentile, for the 15th percentile. So that's the where you only have 15% of the distribution shaded to the left. So I'm just going to estimate that here. I'm going to draw that right about here, and then shade the area to the left. And this little shaded yellow area should be 15% of the distribution. That's a rank of 15 percentile. And I want to find a z-score that bounds the lower 15th percentile. So that's what I'm looking for. So we already know how to go from area to z, so we're going to go to inverse normal with an area of 0.15. We want a z-score, so mean of 0, and a standard deviation of 1. And that's going to give me z equals, let's see, menu, probability, distributions, inverse normal, 0.15. Should be a negative number, and it should be pretty far away from the 0. So let's see. Yep, negative 1.04 is going to be my z-score. So actually it was, so I'm going to adjust this a little bit. So this is 0, 1, just slide that over a little to be a little more accurate. There we go. Okay. Find the z-score for percentile is 75%. So I'm gonna, it's probably somewhere right around here. And then I'm gonna shade the area. That area should be 75% of the distribution. So again, I'm going to grab my calculator, I'm going to do inverse normal, get this z-score that bounds that shaded area. So it'll be area 0.75, mean is 0, standard deviation of 1, and I get a z equals 0.67. All right. Okay, what is the equation to calculate a z-score? We've done it in the past, so we're going to revisit it. Z equals the value you want to standardize minus the mean divided by the standard deviation. So we are going to now transform z-scores to an x value. So we're going to have the z-score, we'll have the mean, we'll have the standard deviation. We're going to have to solve for x. So first you identify the mean and standard deviation of the distribution. Solve the equation above for x. If we rearrange this equation, we'll find that z times the standard deviation plus the mean equals x. So you can use that so you don't have to keep solving it for the intended variable of x. And then interpret your results. The scores on Ms. Hogan's honor statistics test follow a normal distribution with a mean of 73 and a standard deviation of 3.5. Find the z-scores, or find the scores with a z-score, with z-scores of 1.56, negative 2.17, and 0.15. So we're going to use this equation right here, which is a form of the z-score equation. So z, so 1.56, times standard deviation, 3.5, plus the mean, will give me x for this particular z-score of 1.56. For you guys, so 1.56 times 3.5 plus 73. 78.46. So you could interpret that a z-score of 1.56 correlates to an actual test score of 78.46. All right, now we're gonna do the same thing with the z-score of negative 2.17. So this should be well below the mean because it's negative. So negative 2.17 times 3.5 plus 73 will get us that score associated with the z-score of negative 2.17. Hop over to your calculator. And that is well below the mean. So the test score associated with the z-score of negative 2.17 is 65.41. And then last, we'll take a z-score of 0.15 and translate that into an actual test score. So 0.15 times 3.5 plus 73 equals x. So that seems reasonable. 73.53 is just slightly above the mean. 0.15 is also slightly above 0, which is a standardized mean, so that does make sense. And so a z-score of 0.15 is associated with a test score of 73.53. Okay, 4 steps to finding x values given a probability. Sketch the graph, calculate the z-score that corresponds to the given cumulative area, then use that z-score equation and interpret your results. So it's very similar to what we just did. We just have to do an extra step going from area to z-score. And we'll use technology instead of the table. DIOSA scores in the top 5%. So that's way up here somewhere. Of Miss Hogan's honors stats test, scores for this test following normal distribution with a mean of 73 and a standard deviation of 3.5. Let's calculate DIOSA's test score, x. Well, I don't even have a z-score yet, but I do have the area to the right, which is 0.05, but I need for the calculator the area to the left, which is 0.95. So I'm going to go ahead and shade that area, which is 95% of the distribution. All right, now I can first, I'll switch back to my pen. I had to go to inverse normal to get myself a z-score. So my area is going to be 0.95. My mean will be 0. My standard deviation will be 1. And I'll get the z-score at that point, at that same boundary. So the area to the left is 0.95. All right, so it's 1.64. Now I need to translate that z-score into an actual x value. So 1.64 times 3.5 plus 73 will get me that test score that I want. So that'll be 78 point, seems a bit, yeah, that's right? Yeah, all right, x equals 78.74. All right, now this is a word problem, so this is where interpretation becomes important. So I'm gonna interpret my results. All right, I'm just gonna check that on my calculator. There's another way you can do this. You do menu, probability, distributions, inverse normal. You can put the area as 0.95, if she's in the top 5%. Change that to 73. Standard deviation to 3.5. And there we go, 78.75, which is right around what we got when we calculated it by hand. All right, that brings us to the end of this lesson. Thank you for joining me, and I'll see you in Unit 6.